So, we start a new topic today. So far we started on introduce the Navier-Stokes equation, then we did some Fourier transform representation, then instability and how turbulence comes in hydrodynamics and convection also, right. So, I showed you how to get turbulence. Now, we are ready to start discussing about turbulence. Okay. So, but what I am going to tell you today is general, but these tools will be useful to describe turbulent flows. Okay. So, I will basically start with energy transfers and tell you about energy flux. So, this is what we plan to do today. So, energy transfers in hydrodynamic flows. So, it will consist of 3 big modules. So, we call mode to mode energy transfer. So, how does energy transfer go from one mode to another mode. So, we did see how energy flows, I mean energy is flow, rather modes were oscillating. So, somebody is supplying energy, right. So, that we could see from dynamics. Now, we will see from energetic point of view how energy goes from one region to another region, one mode to other mode. Then we define something called turbulent flux or spectral energy flux, and S2 is a cell to cell transfer. In turbulence there is energy transfers. It is quite easy to see. In linear systems we have waves, right, and one wave can exist forever if there is no dissipation. Now, if you have many waves, they do not interact, then they can exist forever, right. I mean in electrodynamics we see many waves, they do not interact and they continue to propagate, but if they start interacting, then some will lose energy to other or some will transfer energy to other, okay, and that leads to cascade of energy or wave breaking, or so that is what we will do. And third is how to compute them in simulations. So, that is what I plan to do for these set of lectures. So, I will give a new formalism which in fact was developed here. It is called mode to mode energy transfer. Okay. So, this we will discuss, and that is a very useful tool to describe various quantities like energy flux being one of them, okay, and also patterns, how patterns are formed. We can discuss quite a bit of this using this tool and shell to shell transfer. So, let us just start with some simple equations. I will derive this. So, that is my objective today, to derive formula for these transfers. So, you have to now recall our discussion in the past. So, I am sure we did enough of this equation. So, you will be immediately recollect them. So, energy of a given Fourier mode, and this we call modal energy, right, modal energy, which is UK mod square by 2, U is a vector, K is a vector, right. So, given Fourier mode UK, its energy is EUK, okay, and in fact that is a definition. Now, this energy can change in time. As I said, nonlinear terms will increase or decrease the energy of a mode, and this I derived in the class. Okay. So, this we did. So, for lot of Fourier modes, the formula is this, it comes from in real space u dot grad u and dot that with u. In Fourier space, this u dot grad u becomes a convolution which is u q u p. So, this part comes from this one and this term comes from here. Okay. So, this we did in the class. So, how many of you remember this? So, everybody remembers it, no? So, now this is coming from nonlinear term. Now, I also showed the pressure term does not contribute, right. This I did in the class. So, pressure term, because pressure is minus I k vector p k, dot this with u star k. So, k dot u k is 0. So, pressure term disappears. So, pressure goes away. So, this was done when I did Fourier. So, we had to use all those technology, I mean all the formulas. So, this coming from nonlinear term, pressure does not participate in energy transfers among Fourier modes. We will come to what pressure does bit later. Pressure does something, but in this it is not participating. Now, external force Fu can feed energy. In fact, we need this like buoyancy or external force, external force can also change energy of a mode. Okay. This again I derived this in earlier classes, and viscous term will kill the energy. This comes from nu k squared uk. I have to multiply this by u star k, and it comes here, and this is force. This is straightforward. These two are easy terms. In fact, one thing, so this is fu dot uk, and I have to take the real part, because to derive this, if you remember, let me just say this, to derive this you have to take the Navier-Stokes equation in Fourier space, dot this with u star k, and then add complex conjugate to it. Okay, so this we did in the class. So that is why all the real comes. Now these two things, these two terms are function only of k vector, local functions. So it is function of fk dot uk, other one is viscous dissipation at that particular k. But these terms involves more modes, k as well as pq, and the condition, of course, you should remember, is p plus q is equal to k. Okay. So this is coming from triad. So not every mode. So well, this p q are related. In fact, they comes from, when I do the convolution, I get this vector k is p q, and of course there are millions of p q's, these triads. So that is why I have this sum p. All right. Now this is for this equation was given many years back, in fact more than 50 years back. Okay, actually right now there is no k prime, so k prime is minus k. Okay, so this what, for this equation it is k equal to p plus q. We will encounter k prime in the next slide. Now this equation is schematically also is drawn like that. So by the way, I mean I should, since I wrote it here, I can replace k by k prime minus k prime, so that I get this one. So then it becomes these u star k becomes u of minus k, or u of k prime. Okay. So as I did tell you that it makes it symmetric. So the equations become symmetric if I write k prime p q. Now instead of writing like that, this way, we can, where it is k equal to p plus q, so it is not symmetric. Here this is not symmetric, no, this one, but here it has become symmetric. Q p k prime, they all go in cyclic order or anticyclic, it will also be anticyclic. Okay. Or so because of reality condition, you must also realize that there will be another vector which is, so k prime is going this way. No, so this I should say k prime. Okay. So minus k prime. So I am just change the sign of so minus k prime, which is equal to k. So I have minus k prime minus p minus q. So we should have two pair. To a reality condition, both of them must exist. So velocity field is real, and I am going to come to this figure C a bit later. Now this is a recap of energy equation. Now let us focus on a single triad. So I think let us go back to this equation. So I want to focus on a triad, right, this triad and its complex or its negative counterpart. So this is one triad, this one KPQ, QP K prime, and this one is other one which is minus K prime minus P minus Q, and the Fourier mode of these two are related. So you know, if u of q, then u of minus q is u star of q. Okay, so they are connected because u is real. Now for, if I just focus on only one triad and its negative counterpart, then this sum becomes simpler. This sum will become simpler. Now how will that sum look like? So it will look like two terms, right? Instead of summing over millions of them, now I have a small thing. So this, so I can draw, let's write like this, k prime p q. Now left hand side is this one u k prime, the right hand side is sum, remember. Now k prime u q u p u k prime, So, I just say that this is one term, but of course, I also have to get, I have to sum over all possible things. So, instead of q I can have also p, not can have, I had to have p. Okay. So, both the terms are included in the right hand side for a single triad.
So, there should be, I think, u star k prime,
because I am using this notation k prime plus p plus q is 0. So, there is no u star. If I was making k equal to p plus q, then there is a star. Is that fine to agree with? Okay. So, this is way to make everybody on the same ground. Okay. So, in fact, you see a bit later the calculation becomes much simpler if I make it symmetric. So, is that okay? So, convolution gives you two terms. Now, this was derived much earlier by Krecknen for a single triad. Please remember, a single triad. Okay. And this called combined mode to mode transfer, and this is Krecknen 1959. Okay. So, ET means I will use the shorthand for energy transfer. So, what it means, this expression, these two terms together mean something. Okay. Now, please keep in mind that I have set viscosity to 0 and my FU to 0 to simplify this, for simplification. So, we do not want to worry about viscous term and we do not want to worry about energy coming via external force. Now, what is the interpretation of these two terms in the right hand side, term 1 and term 2? It tells you that how much energy goes into k prime. So, this is the rate of change of energy, So, energy change per unit time coming from P and Q together. I mean, look, energy is changing. So, if this quantity is non-zero, that means somebody is giving energy. Like as I said, in a wave in an ocean, if a wave is getting energy from nonlinear cup terms, they are of these forms as long as they are incompressible. So, one assumption we have made is incompressible. Okay. So, it is a combined and mode well, actually I should, sorry, I made a mistake. Combined energy transfer, not combined mode. Combined energy transfer to mode k prime from P and Q. So, this 2 k prime from P and Q. So, Krecknen said that there are 3 people and there are only 3 people, okay, A, B, C or k prime P, Q. So, k prime gets energy from other 2. According to Krecknen, I can know only how much money or energy this guy is k prime is getting from other 2. I can't individually tell how much he is getting from B and C. Similarly, B will get energy from A and C. So, Krecknen said I do not know how much A and C will give separately, but I know the total. So, in fact, this is what is derived from energy equation. That is why it is called combined. PQ together giving to k prime, and this is used by Krecknen. Krecknen used it for derive a formula for flux, and the derivation is reasonably long. It is around 4 pages of his paper in JFM. Okay. There is another book who basically reproduces this thing, this Leslie's book, who does this in more words and more systematically. Now, we thought, in fact, there were 3 of us. There was a student Gaurav many years back in 2000, in fact 99, 2000, and Ishwaran. So, there were 3 of us. Then we said, let us try to see whether we can derive how much goes from P to k prime and Q to k prime separately. So, there has to be 3 people. If there is no 3 people, then this transfer is 0, right. If I turn off any of them, then this nonlinear term energy transfer is 0. With the 3 of them, then let us try to decode how much goes from any mode to any mode. Okay. And it was very useful. Well, fluid also is useful for MHD. It also becomes more useful. Okay, it is more useful. So, that was our plan, and we call that mode to mode transfer. Okay. Now, before you go to mode transfer, let us do some more analysis. So, I am coming back again to usual formula of combined transfer. So, this for K prime, no, this you saw in the previous slide. You can also write for P. So, what will the P term give you? So, instead of K prime you just put P, and so UP will be in the right hand side. So, these one thing which is common is that P must be a vector wave number P must be dotted with another wave number. So, this is this has to be there for the receiver wave number, this is by inspection, right, because it is coming from del j uj ui ui. This del j is give you kj, and the kj is coming from here, or if I do for P, then this P will come. Okay. So, wave number of the argument of u must be here by inspection, yes or no? When I take the Fourier, then this becomes kj for k. If I put for P, then this becomes pj, right, it is straightforward. If you are kind of not following it, please stop, because this is critical. If this is the right hand side, u dot, well, I have put ui. So, if I take the Fourier, then this becomes k, and this Fourier of k. So, this becomes kj, and that dot product is coming here. Okay. So, this P. Now, UP will also come, this UP. So, the UP is sitting here, UP is sitting here. Now, convolution involves basically this and that, this term. So, Q, K prime and K prime Q. Here this was a star, when I put this star was coming here for K prime. Now, K prime is a wave number and convolution involved these two. So, that is a pattern, please relook at it in your notes, that is a pattern. So, similarly you can write for Q, there are two terms. So, this Q wave number is coming here and UQ will come here, and these are coming from convolution, and it is symmetric. In fact, we do not need to put any star complex conjugate. So, that is the advantage of K prime plus P equal K prime plus P plus Q 0, fine. Now, if I sum of these 6 terms or sum of these 3 equations, what will I get? Excellent, you get 0. Why it is 0? Excellent. So, this is of course the physical interpretation that this energy is conserved, okay, but we should get it from math as well. Okay. So, how will I get from math? So, let us collect the term of UP UK prime. So, this is UP UK prime, right hand side these are only 2 terms with product UP dot UK prime. Is there any other term with that? None, right? If I sum these 2, what will I get? So, K prime plus P, I get K prime plus P minus dot UQ, UP dot UK prime. What is this? Now, arrows I have, what will I get? What is K prime plus P? Minus Q, and Q dot UQ is 0. So, this becomes 0. If I add, let us say UQ UK prime, this one, what will I get? K prime plus Q, Q plus K prime dot UP. So, that gives you P dot UP 0, and this also gives. So, all the 6 terms we add together, incompressibility condition is invoked here, and they give 0. As a result, the energy of the 3 modes together d by dt is 0, okay, and that is how we prove that energy is conserved in a triadic interaction, and this has a name, is called detailed conservation of energy in a triad or triadic conservation. So, it is not only that energy is conserved for all full box, but it is also conserved for each triad. So, it is more detailed. Yes.
Some mode may be part of another triad.
So, that we will do it later, that I will come to it. So, we are just saying that only one triad exists, and this is the physics of single triad. Okay, if you have more triads, then we will do superposition, but right now let us focus on single triad. Okay. Now, so this is the question which I told a slide before. So, is there a formula for mode to mode transfer? This combined transfer, but now we want to see among these 3 modes how much x gives to y and y gives to z and so on. So, there are 6 combinations, right, and it turns out it is possible, and that is this lecture is about. So, if you remember, Craigton wrote this formula as k prime p comma q. I did not emphasize it, but is there in a previous slide. So, k prime is a receiver and p and q are giver. So, that is why there is a comma, and this is notation by Craigton. But we said, well, p is a giver. So, p gives to k prime, but q is a mediator, it is watching, it is like a it is like a lawyer. So, it does not get, but lawyer will facilitate the transfer. So, this is mediator, and this is a giver and this is a receiver. So, remember there is no comma, but there is a line here that separates the giver and the mediator. So, first argument is a receiver, second is a giver, and third is a mediator, it is like a law, it is a witness. Of course, q will become a giver at some other formula, but then p will become a mediator. So, this in fact you can easily see that this is sum of 2 terms, s k prime p q plus s k prime q p, right. Here q is a mediator, but there p will become mediator and q will be giver. So, that is by definition. If I get from 2 people, then money I get is sum of the money getting from B and C, that is law of addition, okay, and we want to get a formula for this. Okay. So, in this diagram, so we have this triad. So, q is here, sorry, q, p and k prime, and k prime is minus of k, right. So, this k, so q plus p is k, but q plus k prime plus, sorry, q plus p plus k prime is 0. Okay, they form I mean the triangle is not looking so apparent, but you can draw this triangle. I mean, so you can see that this is minus k prime and this is minus, plus q will be going that way and plus p that way. So, they close the triangle. Okay. So, k prime plus p plus q, I need this for my derivation. Okay. Now, so we will derive a formula for this, for this one, and we call it mode to mode, m to m, mode to mode. Okay. So, what is the condition? So, how many? So, I need some conditions on mode to mode transfer. So, how many equations I am going to get? Okay. So, we will get the following first 3 equations. So, what does 3 equation mean? So, Craigton said in the original formula, this is the total energy coming into k prime from p and q, right. This is d by dt of E k prime t. Viscosity is off and force is off. So, that has to be, as I said, is sum of p giving to k prime and q giving to k prime. So, focus on first 2 arguments, and third argument is by definition is a mediator. Now, second equation comes from energy coming into p from k prime and q. So, this is coming from d by dt of E of pt. So, that will be p getting from k prime and p getting from q. Third is mediator. Third equation is d by dt of E q t. So, q is a receiver from k, it receives from k prime and q gets from p. These are known in computer simulation, we can measure them. Okay. Or Craigton said, well, the right hand side of this equation is this. So, given modes I can write down what is S combined transfer. So, right hand side is known, left hand side all the 6 terms are unknown. As I said, there are 6 possibilities: A from BC, B from CA, and C from AB. I need 3 more equations, right? I mean, to get 6 unknowns, I need 3 more equations. So, what is the 3 more equations? So, again by definition of transfers, any transfer, if I get some from somebody money, the other person loses money, right. So, is that right? I mean, between 2 people, like if I get 5 rupees and the other person has lost 5 rupees. So, energy transfer from P to K prime is equal and opposite of P to K prime to P, or if I add them I get 0. You could also write this as minus of that, minus of this term. Okay. So, just add them, you will get 0. Just this again law of exchange. Energy is a scalar quantity and that is how is a number and it should happen like that. Similarly, Q to K prime is equal and opposite of K prime to Q, and same thing for PQ to is equal and opposite of Q to P. So, I got 6 equations and 6 unknowns. Now, I look for a solution. Now, this was in fact the student Gaurav, in fact it was first his idea. So, I said we can write down formula for any one of them, and it turns out the first one in fact is easy to guess the formula actually. Now, it is in all hindsight, it's easy to guess the formula and it works, amazingly it works. Solution is this. So, energy going from P to K prime with Q as a mediator is dot product. Okay, so I just, so K prime is a receiver wave number, no, this is a receiver wave number, dot this with mediator mode, this is a, or it is a lawyer mode, no. So, this is a mediator mode, then receiver and giver are dot product together. So, this is a receiver UK prime, no, it receives, and giver are dot product together. So, that is the recipe. Now, this satisfies equation 1, 2, 3. If you look at Creighton formula, it was this plus, in fact I was trying to emphasize when I wrote the formula. So, now I do not want to go back because it will erase all whatever I have written here. So, if you remember, so this formula was written, the right hand, just focus on right hand side, okay. It was written as K prime imaginary, there was a minus sign, dot UQ, UP dot UK prime, minus imaginary, can people read this? It is slightly small, but K prime dot UP, UQ dot UK prime. Okay, so let me erase. In fact, that is what K prime dot UP, UQ dot UK prime. Okay, so what do we have? So this is identification. So that these two terms are basically identified as, here this UP is given to K prime, and here UQ is given to UQ gives to K prime. So the giver and receiver are dot product together, the modes, and this guy wave number is dot product with the mediator. That is the rule, and it turns out it satisfies first 3 equations. In fact, it is by instruction. In fact, this looks obvious. Okay, why shouldn't this? You can just identify this, then you can solve this. Now, does it satisfy these 3 formulas? Now, can we show this? I mean, so let me just show this, okay, just for complete. In fact, it is quite easy to see, you can easily do this. So, let me show in the next slide, okay. So, is it 0? So, P to K prime and p to p to k prime and k prime to p, if I add them, will I get 0. So, what is this formula? So, minus imaginary k prime dot uq up dot uk prime. I am being lazy, I am not writing the vectors, just too many vectors. And second term is minus imaginary. So, what should be the, now please help me out, p dot, p is the receiver, uq up dot uk prime. Now, up and u, so this is common between the two. So, I take minus imaginary up dot uk prime outside, and this becomes k prime plus p dot uq. Now, what is this? 0, because k prime plus p is minus q. So, this is 0. So, this indeed is 0. So, it satisfies this law of A giving to B is same as negative of B giving to A, or what did I say, A giving to B is same as negative of B giving being to A, yeah, okay. So, this it works for all three of them. So, this indeed is a formula. So, it works, it satisfies all the 6 equations. Now, what is the physical interpretation? We have done bit of temperature stuff, no, scalar quantities. Now, for scalar quantity, the nonlinear term, how does it look like? So, nonlinear term is u dot grad theta, right, I showed that part, okay. Now, I multiply this by theta for energy. So, this will be part of the d theta squared by dt, right. Yes. Now, if I look at the in Fourier language, this becomes, now dot will, of course you can go inside because the incompressible condition, this incompressible condition is critical for this. All this will not work for compressible flows, which so Pratik does. So, incompressibility is very critical, otherwise it spoils the whole show. So, this will come for scalar, which I will do it bit later, okay. The formula will be k dot uq theta p dot, there is no dot, it's a theta is a scalar. So, theta p dot theta k prime and k prime minus imaginary. So, this is a formula, in fact now we know it so well, of course some 15 years or 20 years now we have been working on it. So, this is a mediator, this is a mediator, and this is a receiver R, giver G, and this is a mediator, this is a lawyer, mediator M. So, receiver with mediator, receiver wave number with mediator, and receiver with giver. Now, no dot product, just some ordinary product. Now, I can draw this in some pictorial way. So, this theta k prime is trying to receive energy. So, it can receive from theta p and theta q. So, we are focusing on how much theta p gives. So, theta p is a giver, so it is giving, this arrow, and uq is like it's advecting, this is advection, in fact it's like in fact indeed it is advection of perfume. Theta is carried by u. So, this carrying, this u is a carrier. So, that is why it is dot product with wave number. So, anything which carries is not transferring, carrier is just, it's like a train, it's taking these two passengers who are exchanging money. So, this is a uq right now acts as just a mediator or carrier. So, it does not participate in energy transfer, it is just a carrier or is a mediator in this. So, it is like a wave which is advecting it, and one temperature mode gives energy to another temperature mode. Now, in fact for temperature it is much easy to show and at least make this analogy, and it's I mean a lot of people are convinced by this connection. Now, for Navier-Stokes, that is why I wrote the formula above. For Navier-Stokes equation, you have to identify these two as receiver and giver. In fact, they are receiver and giver, and this is like a mediator. So, these two are dot product together, okay. So, that is why receiver and giver modes are dot product. and the mediator mode UQ. So, this is the giver, receiver, they will be dot product, and this is the mediator. Acha, UU means velocity to velocity, okay. Yeah, I am sorry, I made a mistake. So, this theta theta, theta theta. So, in fact, yeah, so that is one thing notation we keep, because in MHD it will become U BB and UU and so on. For convection it is theta theta. So, yeah, okay, good, thank you. So, for Navier-Stokes we write this as UU, here UU, and receiver and giver dot product, and wave number which is mediator wave number, no sorry, receiver wave number and mediator mode, Fourier mode, I mean Fourier mode, okay, the dot product. Okay, so this is a physical interpretation, and it works. So, that is where I will stop. Thank you.